After Chandrayaan-2, the Chandrayaan-3 mission is the Indian Space Research Organization's second attempt to show that it is capable of safely landing and wandering on the lunar surface. Hi friends, welcome back to Shared TV. From this video we are talking about general facts about Indian Space Research Mission Chandrayaan-3. Before move on, please don't forget to subscribe us. On August 23, 2023, the lander module of Chandrayaan-3, which was carrying the lander Vikram and rover Pragyan, performed the first ever soft landing on the surface of the lunar South Pole. India became the fourth country to make a soft landing on the natural satellite of Earth, becoming the first to do so on the surface of the lunar South Pole. On July 14, 2023, from Sriharikota, the Indian Space Research Organization launched the Chandrayaan-3 mission utilizing the Geosynchronous Satellite Launch Vehicle Mark III, LVM-3. The Chandrayaan-3 mission seeks to bolster India's competence in space exploration and innovation by showcasing the capability of soft landing and roving as well as conducting experiments on the lunar surface. The mission has welcomed India into the elite space club, building on the accomplishments of its forerunners, Chandrayaan-1 and Chandrayaan-2. Let's look at important details of Chandrayaan-3. The LVM-3 rocket system was used to launch the Chandrayaan-3 mission. The new launch vehicle from ISRO, known as LVM-3, has the capacity to economically place modules into GTOs, geosynchronous transfer orbits. It is a three-stage launch vehicle that consists of a core liquid stage and two solid strap stages. The integrated modules were placed in an elliptic parking orbit, a GTO, with a dimension of approximately 170 by 36,500 kilometers by the launcher LVM-3M4. What are the goals of Chandrayaan-3 mission? Finding water ice that could support human life on the moon in the future and providing rocket fuel for spacecraft on future interplanetary trips are two of the mission's numerous objectives. The Chandrayaan-3 mission's goals are safe and soft landing of the lander on the lunar surface. The rover travels on the moon. And rover's on-site scientific investigations. Let's look at Chandrayaan-3 mission components. The propulsion module, PM, and the lander module, LM, are the two modules that make up the Chandrayaan-3 mission. Propulsion module 2,148 kilograms and lander module 1,752 kilograms, plus rover 26 kilograms, have a combined mass of 3,900 kilograms. The lander and rover configuration was propelled by the propulsion module all the way to the 100-kilometer lunar orbit. It carries the lander module as well as spectropolarimetry of habitable planet Earth, SHAPE, a research payload. New spectropolarimetric investigations of Earth will be performed from lunar orbit by the SHAPE payload. In the reflected light, it will search for smaller planets that might be terraformable. A lander, Vikram, and a rover, Pragyan, make up the lander module. In order to perform the soft landing, the lander module used the automatic landing sequence, ALS, which involved starting its thrusters and controlling the speed, direction, and location of the landing site. The rover within it ramped down on the lunar surface after the historic touchdown to conduct in situ chemical analyses of the lunar surface throughout its mission. The mission's, lander and rover's, overall life duration is 1 lunar day, 14 Earth days. Scientific payloads are aboard both the lander and the rover to conduct lunar surface research. Here is the Chandrayaan-3 mission timeline. Date of launch, July 14, 2023. August 5, insert into lunar orbit. August 17, lander module and propulsion module separation. Deboosting is the slowing down of a spacecraft in an orbit where the paraloon, closest point to the moon, is 30 kilometers and the apoloon, farthest point from the landing site in the South Polar region, is 100 kilometers. The first deboosting occurred on the 18th of August, because the speed needed to land is substantially lower than the lander. It is essential for a proper landing. The targeted site on the moon was at around 70 degrees south, close to the southern pole of the moon, on August 20th for the second deboost and on August 23rd for the soft landing. The lander would have to wait 1 month if the start date of the soft landing had been missed. It touched down between the Simpulius N and Manzinus C craters, at 69.36 degrees south and 32.34 degrees east. On August 24, rover started its exploration. What makes Chandrayaan-3 different from Chandrayaan-2? 2019's Chandrayaan-2 mission ended in failure since it was unable to perform a soft landing. The 5 engines on the lander created a higher velocity than anticipated, which was the primary cause of the accident. The lander also needed to take photographs in order to correct the landing site. The cumulative mistakes were created by all of this. The following innovations, which the ISRO had applied after learning from earlier failures, helped it succeed this time. Because of the failure-based architecture, Vikram would have still landed softly even if all sensors and electronics had failed. This was accomplished by recognizing and addressing all likely failure situations that might arise, such as electrical failure, engine failure, inability to arrive at the landing site, sensor failure, algorithm failure, velocity greater than necessary, etc. Chandrayaan-3's target area was maintained at 4 km by 2.4 km rather than the 500 meters by 500 meters area intended by Chandrayaan-2, so that the lander would have more alternatives to select the optimal target site on its own. It was retained to make it easier for the lander to travel farther to the landing location and, if necessary, to the backup landing site. The Chandrayaan-3 mission does not have an orbiter. Instead, it uses the Chandrayaan-2 orbiter's high-resolution photos. Chandrayaan-3's payload weight was kept higher than Chandrayaan-2's, with the lander carrying the majority of the extra mass for a successful landing. Chandrayaan-3's thruster count was reduced from 5 to 4, with no central thrusters. The lander's legs were strengthened so they could land even when traveling at a higher speed. Chandrayaan-3 used extra solar panels to guarantee power generation following a soft landing regardless of the lunar environment. India's Chandrayaan-3 mission intends to advance Chandrayaan-1 and Chandrayaan-2's accomplishments and carry on the country's lunar exploration activities. This project is important for several reasons. Future lunar exploration. The mission can be crucial to India's effort to put people on the moon. The success of this mission will boost the partnership with JAXA, Japan Aerospace Exploration Agency, for their Lunar Polar Exploration Mission, LUPEX, or Chandrayaan-4, among other projects. Enhancing space education. The mission will aim to improve India's scientific mindset and space education. The scientific community and upcoming generations of space enthusiasts may find inspiration in it. Exploration of the lunar surface. Chandrayaan-2 revealed information about the moon's topography, minerals, and water. The lander and rover aboard Chandrayaan-3 are examining rocks and dirt to learn more about the history of the moon, which could indicate asteroid collisions that led to surface changes. Chandrayaan-3, which is focused on the south pole of the moon, seeks finding minerals, underground features, and water in an effort to get new knowledge about the geology and resources of the moon. Scientific findings. Chandrayaan-3 carries equipment to explore underground heat and moonquakes. It will improve India's understanding of lunar geology, resources, and surrounds, deepening insights about celestial bodies. Seismometers on its surface show the moon's innards, and thermal probes uncover crust movements. The mission aims to comprehend seismicity and thermal characteristics in order to shed light on the inner workings of the moon and to advance our understanding of the cosmos. Thank you for watching. Please don't forget to subscribe us.